with the existing car by electric car, the entire economy will get upside down. Like the fuel will not be used, or fuel price has to come down, and so other things, the entire workshop like engine management systems, engine workshop, the lubricants used for engine spare parts. So everything will be has to be modified. Something it has to change to electric cars. The entire business has to be changed accordingly. Okay, and a lot of old generation workers like workshop guys who deals with engine will lost their job, or they have to upgrade to the electric cars. They have to learn new things related to electric cars, and they have to continue the job. So everybody has to upgrade. Even our drivers, as a owner, we have to upgrade ourselves, and as a driver, the driver has to upgrade. As a mechanic, they have to upgrade from the workshop side also. So the technology is getting improved, so we have to improve ourselves also. Similar to our old cell phone or TV. Previously, we have a bigger TV and a separate mechanic was there. So right now we have a flat screen TV. So the electronic guy who has to update himself to operate the flat screen TV. Similar to that, the automated field is also getting changed. Okay. So this is getting changed after an era, something like 40, 50 years after development of this engine. Now we are replacing the engine with the electric motors, which is a very big change in the automotive field. Already from Bosch side, we have closed a couple of diesel plants where there are a lot of emission problems was there with the diesel system. So in Germany, we have closed a couple of production plants for the diesel engine management system plant. Okay, so this is how right now the trends is moving, and a lot of challenges against this automated driving. Let us see one by one. And in today's agenda, the things will be going like this. Just to start with introduction. So how or what are the automated driving mega trends? Why we are going for this automated driving, and what are the mega trends behind this? And there are different level of automation available, like level 1, 2, 3, 4. Like that, we have 6 levels of automation. So we are not directly going to 100% automation. So we have different levels. And disruptive development paths. So what are the other disruptive paths available? Development paths available. Next, what is the automated driving technology? What is the fundamental behind this? And what are the vehicle functionality and architecture for this automated driving? Okay, so we cannot have the old functionality, or the old architecture will not be working fine, because mainly we depend on drivers. Now we are removing the human intervention and mainly depending upon the automotive technology. So the entire architecture is getting changed. Vehicle architecture is getting changed. Next, automated driving release requirement. Okay. So basically, to release a car, so we or release a product in an automotive system, we will be having a lot of requirements, like safety requirements, a lot of challenges which has to be documented and approved by some authorities of each country. So like that, we have a lot of restriction or release requirements should be done for releasing this automated driving. Next, automated driving, continuous engineering. So that means it's not only a single development, then the development will happen further to enhance this automated driving. So it is seen as a continuous engineering development. No, sorry, some external noise, please. Yeah, now it is okay. Yeah. Next, there are a lot of supporting technologies available to have this automated driving as well. Continuous engineering. So we will go upon this agenda in the upcoming 1 or 1.5 hours. Okay. So here there is an comic picture available where we can see two trends. When the car was launched, okay, at the time we have only the horses, carriages with the horses. Okay, so at the time the people think, some people tell that it is an unimaginable thing that without horse we cannot ride a car. Okay, something like that. Each people has their own idea. Some people think it is totally impossible. Some thought that it may be possible, then definitely possible and inevitable. So like that, they have a different thought when we launched a car. Okay, then right now the same thinking is happening when we are coming up with this automated car or driverless car. Okay, so few people think that self-driving car is impossible, and somebody think that it is possible. Something they were telling it as a dream. Okay, I think you can see a couple of old English movies where the James Bond drives a car with automated thing with a remote or voice control. So same thing, which was a dream before some 10, 20 years. Right now the dream is coming true, and everything is getting into a realistic world with the things. Okay, let us see what are the mega trends here. Okay, so first one is the globalization. Why we are going for this automated car? So for that we have a couple of reasons, and what are the mega trends happening in the world. So a lot of things happening, and particularly we are highlighting a few things. One is globalization, urbanization, demography, and 4, 5, 6 is something like energy, health, and weather, water, and seventh one is the technology. Out of this, we are considering only this four categories, which is mainly related to our automotive technologies. First, let us see the globalization. Here, some sayings from different countries, presidents are saying. So, Xi Jinping from China told that we welcome all abroad the express train of Chinese development. Okay, so particularly they were welcoming uh, others for the Chinese development. Next, Trump, previous president of USA, said that let's make America a great again. Okay, so he is also looking for the globalization, that is welcoming others to put efforts or put their money into the other country's development. Okay, that's why every country is looking for globalization. So previously the market is within a country or within a continent. Now, even if you want to get a thing, we are importing it from other countries. For example, if you want an mobile, you can order it from any country, then you can get that mobile, just a duty paid, and you can get it here. Even if you want a small electronics item, you can import it from China or Vietnam. So it's getting a globalization everywhere. Even through online, you can order. A normal people can order devices online from other countries. So that is the trend happening here. And economic dependencies on world trade and global value creation. So everything is creating global value. So the value within a country is not only defining the company's strength, so the global value should be available for each product. Okay? And the complexity in technology. So the technology nowadays is getting very complex day by day. For example, the automotive sector was previously available only with the developed countries like Germany and USA. Right now, we are developing certain technologies which is country specific, okay, and according to the market situation. For example, in India, we are bringing a lot of sophisticated features in a normal car, okay, to make the car saleable. So we are trying to bring a lot of features in a low-end car itself to increase the market. So such that the complexity in technology is getting increased day by day. So we need a lot of collaboration between each countries and the partners available with different countries. Okay, and also the next point, stringent legislation and norms. Okay, that means each and every country is putting the rules or updating their legal requirements. So updating the legal requirements day by day, so which is causing this issue. No.
அன்பழகன் சார் வாய்ஸ் கேட்கல.
Ma'am, is the presentation
ஓகே.
visible?
பிரசன்டேஷன் இருக்குங்க. வாய்ஸ் மட்டும்.
Okay, okay.
ஓகே ஓகே ஓகே. இப்போ நான் ஆடியோ.
Okay, just a moment. I can't able to see my screen. That's why.
So presentation is also not.
Just a moment. I will stop sharing and I will share it once again. Sorry. Can you able to see my screen now?
சார் இன்னும் வரலைங்க. டிஸ்பிளேல இருக்கு. லோடிங், இட்ஸ் அண்டர் லோடிங் கண்டிஷன்.
Okay, okay.
ஸ்க்ரீன் இருக்கா? இன்னும் வரல தானே விஜய்?
Sir, it is not visible, sir. Screen is not shared. Sir?
அன்பழகன் சார். அன்பழகன் சார். Anbaran sir. Anbu sir, can you hear me?
Yes, ma'am. I can able to hear. Sorry, I will
Okay,
share my
okay,
screen.
no problem. No problem.
Ma'am, let me know once my screen is visible.
So screen is visible, but the PPT is not visible. Screen is visible, sir.
Okay. So can we continue, ma'am?
Sir, not able to see the PPT, sir. Presentation is not.
Presentation is not visible, ma'am. Right?
Ah, yes, sir. Presentation is not visible.
Okay. Is it visible now, ma'am?
Ah, sir, Zoom window is visible, sir.
Okay. But my screen is not visible, right? My
Yes.
presentation is not.
Presentation is not visible, sir.
Okay, ma'am. Is it possible to share an email that I can forward my presentation? And I think you can present it.
Okay, sir. I'll message you, sir.
Yeah. Sorry for the trouble. Something happened.
Anbalavan, sir.
Yes, ma'am.
Anbaran sir. karpagam.j@kprit.ac.in.
Yes.
Okay.
At kpr.it.in, right, ma'am?
Okay.
kprit.ac.in.
kprit.ac.in, right?
kprit.ac.in.
et.ac.in.
KPR Institute of Engineering and Technology. .ac.in.
Okay. Okay. Yeah, right now I'm sending the presentation, ma'am.
Unbalanced, sir.
Hello.
ஒரு நிமிஷம் 1 minute, sir. 1 minute.
மேம் எனக்கு டெஸ்க்டாப் ஷேர் பண்றதுக்கு அக்சஸ் கொடுங்க மேம். எனக்கு இப்போ அக்சஸ் இல்லை.
ஓகே ஓகே ஜஸ்ட் நான் டெஸ்க்டாப் ஷேர் பண்ணுறேன். கோஹோஸ்ட் கொடுத்தேன். அன்பழகன்
மேம்
என்ன நேம்ல இருக்கீங்க? எந்த நேம்ல இருக்கீங்க?
ANT to COB official ID.
Just a minute.
Okay, ma'am.
The co-host check பண்ணிக்கோங்க.
Okay, ma'am. Just a moment. இப்ப பாருங்க மேம், விசிபிளா இருக்கா?
ஓகேங்க சார். now it's visible.
Okay, ma'am.
Okay, thank you.
Okay, ma'am. Hope I can continue from here.
Yes sir, you can continue.
Okay, thank you. Sorry for the inconvenience, guys. Something happened and my PC got corrupted. I installed a new PC and I'm continuing. Okay, so as a global trend, so we are seeing that globalization is one of the mega trends at a global level. Okay, and we have a lot of complexities in technology sharing between each countries. So we have to depend on each countries. We cannot create a product within a country. So we are depending upon the technology sharing and collaboration and partnership with respect to the complexity product development. Okay, and a lot of stringent legislation and norms were created for each country. So we have to depend on other country for the other legislation norms to prepare it. Okay, then as we all know that whatever the product released into the market, so we have to release at the first, then only we can keep the market up. Otherwise, if we are the second, then we will be at the loser level. So the time to market is a first thing which we have to cover, and everyone wants to ensure their position in their market as a first level. So we have to launch our first product as a first product in each and every part of the world. So globalization is a big thing which everybody looks into. Next, just a moment. Sorry. Yeah, second one is our urbanization. Okay, so as you all know, So urbanization is getting a very big thing, and we see the world is a city. Previously, we see it is a far away part when we want to move from one part of the world to other part. Now, within some 36 hours, we can move from one part to the other part. Maximum within 36 hours, we can move to other part of the world. So we can rotate in clockwise, and also we can rotate in anti-clockwise direction in the map. So we can it is possible for the urbanization. So mainly we think that the people moving towards the city is getting increased day by day. Okay, so because of this, congestion and stress is getting increased, and they feel that the time is directly proportionate to money. So everyone want to utilize their time. So even right now, when we do work from home, so the travel time to our office is getting reduced, and we are trying to make use of the time. So which is telling that the time is directly proportional to money or equal to money. Okay, and mobility point. So people want to move from one point to other point, and they will not follow one route. Okay, and multimodal transport is preferred in the connected world. That means, so everybody is thinking of moving into a car or a cab, and want to utilize their precious time for increasing their productivity. So they don't want to drive in future. Okay, and the population is also getting increased day by day, and some countries are promoting public transport and electric vehicles to solve this pollution issues. Similarly, in India, even in Tamil Nadu, we are trying to bring the public transport to all places. Now also the electric vehicles to reduce the pollution. Even from our office, so we are trying to get the public transport used for most of the case, particularly in the morning time. The people rushes towards the city, but our office is at the outer. So the return journey of the bus is always free. So the return journey of the public transport is used by our company. So this is a part of how to utilize this public transport effectively. Next, demography. Demography means the aging of people is getting increased day by day. That means the entire human lifetime is increased. The average lifetime of human is increased from 60 to 65 nowadays, and it is also getting increased day by day. So the aged people want to move from one place to other place, and to get their basic needs like food, or they want to work, or they want to go for an movie or some other thing for the basic purpose. So they want to be mobile. Even though they were aged, they want to have a safe mobility. So for this, we are trying to introduce our automated vehicles where they don't depend on, they don't need to depend on the other human beings or other assistants who is helping them. So that is one thing. And also the technology. Yes, you all know the data is the new oil for the system. Okay. Similarly, the technology is also getting increased day by day based on the data. So you know that big data, uh, all the sensors in the vehicle network are connected, and they were uploaded into the data are uploaded into the cloud, and it serves as a big product in the world, and it plays a major role in the technological development. And the new algorithm is coming into picture, like artificial intelligence, machine learning, deep learning, which plays a major role in giving the solution to each and every product. Okay, and the data should be kept privacy, and the ownership of data to be handled properly. That means the policy and securing personal data plays a critical role here. For example, if some company is getting a data from us, and they should be liable to keep the data as a privacy data, and it should not be shared with any others. I think recently we are getting the information that WhatsApp is sharing our data with others. So there is a big loss to the WhatsApp market, and new products are upcoming. So this is how we look into the technology part and how to work on this automated driving with the technology parts also. And a new business model is also emerging based on this technology. New business model is emerging that we are going to see in the upcoming slides. Similarly, CE integration, photo, security, V2X, V2I. So these are all becoming the norms. So photo means flash over the air. So how our mobile software is getting updated with our mobile network. Similarly, car software, the electronic units or the embedded system in the car and its firmware will be updated over the air. Whenever you connect your car to the internet, then all the required software or updates will be coming into your car, and you can get it updated like our mobile softwares right now. Similarly, security is also getting increased. I think if you see some videos in YouTube about the car hacking, you can see a lot of guys are hacking the car. Similar to hacking of our computers, the cars are also now connected to the internet, and it can also be getting accessed by others. So security plays a major role here. Then V2X. V2X means vehicle to vehicle communication. So the car can communicate with other car. Okay, and the data from one car can be shared with others. Similarly, V2I means a vehicle to infrastructure. For example, a toll gate is a best example. So a toll gate is an infrastructural thing, and our vehicle is coming. Whenever our vehicle is coming in near our toll gate, so the amount from our account is detected and the gate opens automatically. So this is nothing but your vehicle to infrastructure communication. So everything becomes a norm. So the technology plays a major role nowadays. So some 10 years before, the automated toll was the toll itself is a big thing to us, and the automated toll is a dream for us. Right now, everywhere the automated toll is coming now. So the technology is getting developed day by day. Next. So far we have seen the mega trends happening around the world, and here we have three trends, mega trends in the automotive field. Okay, so first one is the electrification. Okay, so electrification plays a major role. As I already told, this is a mega trend of this era. So the entire IC engine, internal combustion engine, will be replaced with the electrified motors. Okay, so the existing car also, the some startups are working towards electrifying the existing IC engine cars. So they were trying to remove the engine and fit a motor inside with a battery. So they were trying to electrify the existing car itself. Okay, so a lot of such development is also happened. Okay, the main thing is cost. Whenever we are going for the electric car, right now the battery and the charging system of the car is under development, so the cost is at high. Okay, and we are looking for the hybrid cars with a motor and an IC engine, and how to make it as a hybrid. Then e-motor is also available, e-bike, a lot of power electronics involved over there. And plug-in. So we need to plug in our system whenever there is a charge needed. So we have to plug in, and the range of the system. And it is very fun to drive an electric vehicle. So there will not be any sound. So to get a feel, so the customer needs some sound, like the engine is running. Whenever you are accelerating, so the sound should also increase. Then only we will get an feel of driving a car. So, and the sound can also be changed, so such that we can have a fun, or we will have a fun when we drive an electric car. Okay. And the battery and charging infrastructure, as we all know, right now we are producing a lot of electric cars, and the battery capacity also very minimum, so we can drive up to maximum of 300 or 400 kilometers, and we need to charge in between. So The battery technology is also under development, and the charging infrastructure is also under development. Right now, when we start from Bangalore to Coimbatore, I think there is no charging station available, and our government is trying to bring charging station in all the petrol pumps. Okay. When that's why they were giving an approval for a lot of petrol pumps inside and outside city, and where the charging facility is also available. So that's why our government is increasing the norms of bringing a lot of petrol pumps. Next, coming to the automated thing. So first one is our electrified thing, then automated thing. So why electrified trend is the first thing which we kept here. So whenever we are trying to automate, the control of each element inside the car should be easy. For example, controlling an IC engine is very difficult. Okay, but controlling an electric motor is very smooth. For example, whenever you do a speed control of a motor, you can bring the speed of motor to 0 to the maximum rated RPM easily. But here in IC engines, we cannot bring down the engine speed to 0, because engine will always run at ideal RPM. Whenever it goes below the ideal RPM, it will be jammed. So the engine will be locked. So it will it's called as an engine stalling. The engine will stall and it will stop rotating below the rated RPM. Okay, so something around 500 or 600 RPM, below that it will be stalled. So that's why electrification of a car is a basic thing for automated cars. Okay, so for this automated cars, a lot of problems, as I already told about the legislation and the driver assistance. So there are a lot of issue with bringing this automated car into each country. A lot of countries are encouraging, a lot of countries are framing stringent rules to avoid the unsafety conditions. Next, emergency braking. So whenever there is a person coming into this car, so this automated car should brake immediately. So emergency braking and autopilot. So without a driver, how it will be driven. Then highway pilot and redundancy of sensors. So basically here the automated driving depends on the lot of sensors. So every sensor will be replaced by the other things, or every actuator will be replaced by some other thing. So redundancy plays a major role here, and they don't want to create an safety issue. That's why a lot of redundant sensors are also used. Okay, then here we have this robot taxis, so which we will be seeing in the upcoming slide. What is robot taxis? Next, connected cars. So after developing this automated cars, so it should be very intelligent enough, okay, in getting the data. So it should be connected with between each other or with the cloud. Okay, for example, if there is a traffic jam in road, the traffic jam information should reach the car well in advance, and it should take a different route to avoid the congestion in the road or traffic jam in the road. That's why the connected car is a major thing which we are looking for the upcoming development. So this will become a major thing after the development of automated cars. Next, let us see what are the automations level. As I already told, there are different level of automations available. So from level 0 to 5, so totally 6 levels are available. So this is classified based upon the driver presence inside the car, or driver need of driver in a car, okay, or the level of driver availability in the car. So level 0 means no automation. That means steering, acceleration, and deceleration. That means steering, accelerating, and braking. So these things has to be taken care by the driver. Okay. Next, object and event detection and response. So whenever there is an object coming into picture, so when coming inside the car, so the driver has to take care of the control. And fallback, whenever the car is under a trouble or with some problem, then the driver has to take control. and he has to repair the things and get it corrected. And system capability, so that means what are the things automated. So level 0 means no automation, so none of the things will be taken care by the system. So level 1, so driver will be assisted. So the driver should present, but the system will assist the driver in accelerating or decelerating. Okay. Partial automation means the full system will be controlled, like steering, acceleration, deceleration will be controlled by system. So other things should be taken care by the driver. Conditional automation means even the object detection will be controlled by the system. Okay. High automation means full, even if there is a problem in the car will be taking care of the problem. For example, if something happened to your car, then it will safely park the car in the roadside. Okay, it will take a left turn and park it at a safe parking space, and it will tell that there is some problem in the car. Okay, but in a full automation car, everything is defined. That means all things will be taken care. Even if the car is under a problem, so it will take us in a safe mode. So that means it will drive slowly. If there is a problem, it will drive slowly, and it will take us to our destination, and the car will automatically move to the garage for repair. And once the repairing is done, then it will come back to our home for picking us. So this is nothing but your fully automated device level 5. Okay. So level 1 and 2, so which reduces the stress while driving. That means still the driver is driving, but it reduces the stress on driver and increases the safety. Level 3 to 5, so which increase the productivity through the driving time. So no need of a driver to drive the car. So it will drive, and we can look after the other activities. We can increase our productivity. So level 3 to 5, so no intervention of driver for driving the car. So this is the different level of car automated driving system. The same thing is given here with a different functionality. So level 1, so ACC lane keep support. So for example, whenever there is a lane, so we will support us in keeping the lane. If you are coming out of the lane, it will warn the driver that you are moving out of the lane. Okay, so this is just assisting the driver. Okay. Second, level 2, traffic jam assist. Okay, so driving in a traffic jam is a very hectic job. So this function will help the driver to drive the car in the traffic jam. So it will follow a car, and it will go at a speed of 0 to 60. So just follow the front car. Whenever the front car stops, this will also stop. Whenever it moves, this will also move. Okay, so the speed range will be 0 to 60 kph, and it will be mainly used in the traffic situation. It is called as traffic jam assist. Next, level 2. Level 2 is nothing but a highway assist. So whenever you are driving on highway, so it will take care of the driving car on highway. So the lane change after the driver initiation, and supervision of surrounding the traffic, and next lane ahead and behind. So it will give all the information well ahead. So what is the thing available in front of you and at the side of the car. So all the level informations will be shared to driver, and only the driver needs to look into this and take decision. That's it. Already it will be having all the decision levels. Only he has to take decision. Level 3, traffic jam pilot and highway pilot. Assist means it will assist only the driver. Pilot means it will drive for us. Okay, so no need to take care of the driving even in the traffic jam and highway. So that's why it is called as traffic jam pilot and highway pilot. Okay. Next, level 4, exit to exit. So this is the highway pilot. So from one point to the other, from exiting of the door to exit of the our car door. So that's why we have this exit to exit concept. So driver can sleep or enjoy the infotainment while he is on the highway. So such that no intervention of driver required here. Okay. Next, urban automated taxi. Okay. So here, when like how we are booking a taxi right now with Ola or Uber, like that we can book a taxi, and a car will come in front of you, and car will come in the door in front of your door to pick you up and it drop you to the destination location. That is called as nothing but your urban automated taxi. Okay, so a taxi will be there and there will not be any driver, and only a car will be available. Even the driver, we can occupy the driver's seat. You can see the image here. So 4 persons can sit around a round table and chat or do a conference or something like that. So like that, and this is nothing but your future concept of urban automated taxi. Okay, and this different level of automated driving is work based on the sensor signals. Okay, so see, you can see here that light blue is a single sensor, then dark blue is sensor data fusion, and very dark blue is the sensor data fusion plus map. Okay, so you can see the level of sensor available or supporting the automated driving here. Okay, so from light blue to the dark blue, so that is nothing but your single sensor to the sensor data fusion plus map. Okay, so this is how the involvement of sensors in the automated driving. Next, difference towards the high automation. Okay, what is partial automation, what is highly automated? As I already told, so the decision making will be taken care by the system in both the things, and the responsibility still lies with the driver in partial automation, but a highly automated device will take care of the responsibility by itself. Then insufficient actuation, so driver has to take care of this. Here it is not permissible, that means driver is not allowed to take control over that. Okay, only automated driving is possible. Covered situation, so that means only a selected situation cases will be done by this partial automation, but highly automation will work in all situations. So system failure, whenever there is a system failure, fail safe or mode will be there, and it can be taken care. But here fail operational, that means even in the fail, so the car will be operative and take you to the destinated location. Okay, so the high automation requires the redundancy of sensors and the redundancy of ECU, communication, and actuation. So everywhere it needs a redundancy. Okay, so we will see how the redundancy will be done in each car for the automated things. Okay, next, as I already told in the agenda slide, so there are a lot of disruptive development paths available. Okay, evolutionary and disruptive paths available. You can see the vehicle. There is an evolution or revolution happening in the automotive field based on the vehicle ownership and the vehicle automation. You can see here in the x-axis, you can see there is a vehicle ownership. Okay, and who is owning the vehicle, whether we own the vehicle or we rent the car. Okay, next, vehicle automation, whether we drive the car or whether somebody is driving or whether the things are getting automated. Okay, so right now we are having a small change. Right now you can see this side, so here also we have the same thing. So still the ownership is with the individual, but the driver is driving a car. Okay, this will be a small development. So instead of us, the driver will be driving the car, and we will do our job and increase the productivity. But we have to pay a lot to the driver, like a salary we have to pay. So it's costly. Okay, next, still the ownership is with us, but the car is automated. Okay, that means we will eliminate driver and automated private cars will be available. Okay, that is called as our private car as PC. So this is the evolution which is happening. Next, when you see the ownership, right now in few peoples are not ready to own our car. Okay, so owning a car is a bigger thing, and we have to invest a lot of money, and we have to take care of the car service, car maintenance. A lot of things are there. We have to pay the insurance. and whenever there is a problem, we have to take it to the showroom. So a lot of things are there. So instead of that, they were trying to share the car. Right now we have the sharing of car by with Ola or Uber also. Even the taxis can be shared within us. Okay, so still the driver is there, but the ownership, that means a car is shared. It is nothing but a taxi. Okay, next, in future, so there is a revolution going to happen. So automated car, shared car is available. That is nothing but called as your urban automated taxis. Okay, and a taxi will be there, and this can also be shared, something like how we are sharing our Ola or Uber taxi. So automated taxis can also be shared. So that means the vehicle is owned by some company like Ola or Uber, and there will not be a driver, only the automated cars will be coming. So this is nothing but called as an UAT, urban automated taxis. Okay, so this is how the things are, the descriptive development is happening. Next, a lot of advantages and disadvantages of your private car and urban automated taxis. So let us see what are the things happening in the private cars. The revenue of selling L3 equipped vehicles. So that means, so the private cars are nothing but your L3 cars, level 3 automated cars. So autonomous drive package will be available on your ADAS. ADAS. So ADAS means automated development and active safety packages. So this increases the safety and the time can also be saved. So this is the major advantages of your for the end customer. Okay. So traditional OEMs only, that means the normal car manufacturers only is going to update the private cars for the individuals. So long-term key success factor is the reliability available and safe for end customer. So that means whenever the traditional OEMs are planning a car, so it will be reliable because already they were manufacturing cars, so and it will be reliable. Okay, and the time will be freed up and can be used efficiently or spent pleasantly by the end customer. That means we can sit inside the car and enjoy the time or make it effectively utilized. Next, urban automated taxi. So this they will call it as a green world. So where the pollution, they were trying to reduce the pollution. Okay, so end customer pays mobility service provider. Okay, so that means like Ola or Uber. So end customer will pay to the service provider. Okay, for each kilometer how much they have to pay. So like that they will provide, and the revenue for the mobility service will be available like that. Okay, and system value, that means no need of a professional driver, and utilization rate will also be getting decreased. So whenever there is a reduction of a driver, so a lot of cost can be eliminated. Even though the taxi is not running, no need of paying the salary to driver. Okay, so like that we can utilize the utilization rate will come down. So a long-term key success factor is early development to reach high market share. So they were trying to develop, everybody is trying to develop this UAT, like a Chrysler, Volkswagen, Audi, everybody is trying to develop this. Okay. Then high system availability for a rapid ROI, return on investment. Okay, they were looking for the high system. So mainly they want to reduce the congestion and increase the convenience. So this is the major advantages of your urban automated taxis. Next, privately owned car, how this will work. So with the L3 function, for example, as I already told, traffic jam pilot is a base thing. Okay, so it is called as TJP base. Okay, so user wants to say that I would like to do something productive when I am stuck in traffic jam. So this is nothing but the end user's objective. Okay, so user benefit is the traffic jam pilot takes over slow and stop and go. That means it will stop, it will go slow, and even at some faster speed up to 0 to 60 kph, so it can reach. Okay, so no need of driving cars in the traffic situation. That means no need of applying clutch, brake, accelerator. So the driver can take the hands from the steering and also close the eyes. He can take rest or he can do some other task productively. So this is nothing but your traffic jam pilot. Okay, and a highway pilot. Similar to your traffic jam, the highway pilot can also operate in highway at a very high speed of 130 kph. Okay, so here also the hands can be taken off, eyes can be closed, and very rare to hands over. That means whenever there is a critical situation, the system will alert the driver, I cannot able to drive the car further, please take control. Like that it will alarm the driver, or sometimes it vibrates the seat to yeah, take care of the driver's attention. Okay, so like that we have this highway pilot also. Next, urban automated taxi. So shared urban segment with a L5 or L4 function overview. So here the major requirement of the end user is they want to move from A to B in a city quickly, conveniently, and affordably without parking hassles. As you all know, right now the parking is a very big issue. Whenever you are trying to enter the city center, then it's a very big trouble for us to park the vehicle. But when you use the taxi, you can get down and you can release the taxi, and the taxi can move. Okay, so this is the main requirement for the customer. And benefit for this urban automated taxi is they can move from one point to the other point without any hassles like parking, and at the lower price also they can go, and it is affordable. Okay, so that's why they were focusing on the level 4 to 5 urban automated taxis. Next, okay, from Bosch point of view, we are seeing a roadmap that like level 2 to 3, so automated driving on highways. So here we are planning with highway assist with L2, traffic jam pilot, and highway pilot. So this is classified into a different category. And the urban automated driving, so here urban automated taxi and urban pilot, so this is seen as a separate segment. And automated parking, so this is also seen as a separate requirement. So this is how Bosch looks into the requirement from the customer. Next, these are all the benefits of self-driving cars. So we can improve the safety of a car. So the reduction in motor vehicle accident will have reduced. That means the accident in the car will get reduced, because there are a lot of self-driving cars where it can cooperate between each other. So the car can communicate between each other and reduce the car accident. So the priority can be assigned between the cars. Okay, and it will reduce the accident and increases the safety. Democratization of mobility. So all age of people can be mobile with the help of this automated driving. They can enter into this automated urban taxi or individual car, and they can move from one place to other without any driver influence or any other person's influence or any other person dependency. High fuel efficiency. So data says that up to 39% improvement in highway fuel economy. That means it will save a lot of fuel when we use the automated driving. And the next one is the reduced congestion. 80% improvement in traffic throughput. That means the car will be cooperating with each other and reduce the congestion. Right now, the congestion is happening because of a non-cooperation between the drivers. So that's why the congestion is created. And next one is a gain in productivity. The data is telling that 56 minutes per day will be freed for the user if the automated driving is coming into picture. Okay, so which means around 1 hour of everyone's lifetime will be saved, or it can be utilized for other purpose. Okay, next technology. So let us see what are the fundamentals of things which is required. First, we are taking care of the safety, which is a non-negotiable thing in a car, because car is a main thing where we move from one place to other at a higher speed. Okay, and a lot of mechanical and electronic equipments involved, and we are also going for this automated driving. So safety is a major thing which we are not negotiating and concentrating on the safety part. Similarly, the other things like legislation, the legal rules in each country has to be followed, and security. As I already told, not only thefting of car. Right now, the hacking of a car with their data also plays a major role. So cyber security is also introduced, something like our antivirus thing. So they have also set it into the car, and the cyber security is also implemented there. System architecture. So the entire system architecture itself got changed. I will show you how the architecture changed. And surround sensing, as you all know, it has to sense, since the car is automated, so it has to sense what is happening around the car. So surround sensing system is also available. Then localization. Localization means getting everything local. For example, the local maps will be downloaded, and the local data information. Whenever car enters into a region, the entire map is downloaded, and all the information related to that area is also downloaded. Next one is the decision making, which is the brain part of the algorithm. So artificial intelligence and machine learning algorithms are implemented to make this decision very effective. And validation and release process. So this is a major thing. So the some authorities, like in India, we have ARAI authority to validate and release the car in the market. Okay. So we have these are all the fundamentals for our automated driving. Let us see one by one. Okay. So let us see how we are how our things are working. So here we can see how we are making or creating the driver's absence, or how we are taking care of the driver's absence. Okay, let us see what a driver does. Okay, driver will sense through his eyes. Okay, and check what are the things are in the surrounding. For example, he will look into the surrounding, what is the object in front of him, what is the distance between the next car and this car. So like that, he has his sensitivity eyes. Okay, and he will think what is happening and how this is done, how this can be done. Similarly, we have to replace the eyes. Okay, or the activity of eyes should be taken care with some sensors. Okay, so that's why we have a lot of sensor like video, radar, lidar, and ultrasonics. Okay, so here we have around a four type of sensor. Okay, why we have this four types of sensor is, so it has to be redundant enough. Okay, for example, video will give you an video image. Okay, radar cannot give a video image, but the radar waves can pass through certain things and identify whether it is a real object or it is an something like a fake object. Okay, and the lidar, the light can travel at a very fast range, and it can find out the objects and get the data information. Okay, and ultrasonic is also very cheaper at cost, and it can give a feedback without any obstacles. Okay, so each one of the sensor has its own advantage and disadvantage, but this everything will replace only the eye part of a human. Okay, where it plays a major role. Okay, next, similarly, so video, radar, GNSS, scan, inertia. So these are all the things, sensor which is used for the location, finding a location. Okay, so in which X and Y coordinate our car is standing, and where to move, right or left. So all the things will be taken care by this location sensor. Okay, next, think, perceive, and plan. So how to think and plan. So we have the sensor data fusion. So that means all the inputs from the sensor will have a data fusion, and the software redundancy will also be available. Okay, so take care of this. Okay, next, safe and legal driving should also be taken care. Okay, not only with the help of sensor. So the car has to drive safe and with the legal requirements. For example, if somebody is entering into the road, so the car has to stop immediately, and whenever there is a speed limit, so we have to follow the speed limit. Okay, whenever there is an no entry, so we have to follow the legal rules. So this type of things should also take care. Okay. Next, actuation. So for a control system, we will have this sensor part, decision making part, and the actuator part. Similarly, we have a basic control system in the car, and the actuation will happen through the steering. So based on the sensor data, so we will steer accordingly, whether we have to go right or left, and whether we have to apply brake. So this is nothing but your brake system. This is nothing but your throttle. That means acceleration system. Okay, so whether we have to apply brake or whether we have to accelerate. So this is nothing but the actions happening over here. Okay, and here also we have a redundancy in steering, brake, and system. Okay, whenever the steering fails, so the brake system will help to steer the vehicle. Okay, whenever the steering system, brake system fails, there is a redundant brake system available. So we can see the upcoming things with the redundancy. So here it is telling the importance of redundancy. So redundancy is crucial throughout sensing, thinking, and acting. So everywhere we should have the redundancy in the automated driving. Okay. So here let us see a car where how it senses the 360-degree what is happening around the car. So we have a long range radar. So detect the long range objects. Next, a mid-range radar to sense the mid-range objects. Then LiDAR, so light-based radar is also available. Then camera is also available. Then ultrasonic sensor, which is the cheapest, and we can fit it around the car and sense 360-degree. And ultrasonic sensor and near-range camera at the side direction, and mid-range and long-range radar at the rear side. So these many sensors are kept in a car for 360-degree surround sensing. Okay, so that's why we have a lot of redundancy in the sensors here. Next, localization. As I already told, whenever you are entering into an area, so that area local map should be downloaded immediately, and the signs like a signboard, whenever there is a problem in the road, so all the information will be shared. The local information will be downloaded into the car, and the car can work fast. No need to depend on the live data. Okay, so the constant features will be downloaded before entering into that area. Okay, so this will have the precise map for planning and localization. Okay. Next, accurate localization enabled by Bosch road signature. Okay, so right now Bosch is planning for an localization. So that means whenever there is an signal, so the video road signature data. So whenever there is something available, so then that will be uploaded into the cloud. Okay, then radar road signature data. So everything, all the data in the road will be uploaded into the cloud. Okay, and this will be putting into the Bosch IoT cloud. Then it will be given to the map provider. Then it will be given to the OEM, so the car manufacturer. So the car manufacturer can download it from our cloud to other cars also. So the data at this location can be shared to this car through the cloud. Okay, then all the information like hazard spots and speed limit, traffic information, everything will be shared with the next car. Okay, so which is very useful, and the localization data can be very effectively utilized. For example, if there is a traffic jam in this road, then the car will avoid entering into this, so they can take a different route and divert into a different direction. So localization plays an important role here. Next, perception, putting it all together. So surround sensor, online map data, so everything is together to get this perception. That means probabilistic fusion of all information into single surround model. So all the information will be put together to sense the objects in front of us. Next, low speed autonomous vehicle. So you can see, so sense, think, and act part. So whenever there is a vehicle available here, so it will sense that there is a car available, and it will think and decide you have to take a left turn, and correspondingly act will be done. That means action will be performed by steering to the left direction. So this is how the low speed autonomous vehicle work with low speed. Then next one is the driver is no longer the feedback solution. So that means whenever the car is in a fallback situation, no need of a driver intervention. For example, today we are depending on the driver. So tomorrow what we will do is that with the help of a redundancy, so we will take care. For example, if the steering fails, there is a brake system unit like called as an ESP, where individual wheels can be braked. For example, if the steering fails and you want to take a right, then the brake will be applied to the front right wheels. Okay, so front right wheel will be slow, and front left wheel will be fast. Okay, then automatically the vehicle will turn right direction. Okay, so whenever there is a problem with steering, our ESP system will work. Okay, whenever there is a problem with your brake system like iBooster, ESP has the advantages of applying brakes to individual wheel and also to all four wheels. Okay, so with the help of ESP, so we will stop the car. So this is how our redundant things work. Okay, similarly we have redundancy in sensors like radar, video camera. So a lot of devices are available. So we have different sensors at different redundancy levels. Okay, this already we have explained at the first about the partial and high automation, and here we are seeing the redundant system. Okay, so you can see the environmental sensing with the help of sensor, and localization data is also available, and with the help of connectivity cloud also we will get the information. So all the information will be shared. So analysis, planning and control will be or decision will be made at the central processing unit. Then from here the action will be performed with the steering, braking and accelerator. So this is the basic control system how we act. And here you can see the redundant system. So it is directly divided into off. Okay, so steering torque control so will be happening here with the method 1. Similarly, power will also be given. Communication bus, so this is nothing but your CAN communication bus. Okay, CAN or FlexArray or CAN FT. So communication will be there. Then processing unit will be there, and a power stage will also be here. Okay, and a motor is there to control the devices. Okay, whenever this one of the part of system 1 fails, then system 2 will come into picture. Okay, similarly steering torque 2 is there, which is equivalent to start 1. Okay, power also power 2 is there, similar to power 1 we have power 2. Processing unit also we have a redundant one. Communication channel is also the redundant one is also available. Battery backup, battery stage, so we have a second battery line, power line, everything. There is a redundant system available in the automated driving car. So even though if one system fails, the other system will come into picture. Okay, so that is the main idea of this slide. Then release requirements, as I already told, safety in automated driving is a major thing. So we need to go with maximize safe function and system behavior, and minimize the known potential danger behavior, and minimize the unknown areas. So we are mainly concentrating on the safety in automated driving. Okay. Next, a couple of challenges are listed down here, and new approaches is also coming up. I will tell you about the different layers. Because of the time constraint, I am making it fast. So different layers of security in vehicle is also available. For example, there will be a lot of electronic unit in the car, so which should not be hacked. So individual ECU security will be available. Then secure in-vehicle network. For example, there is an in-vehicle network which communicate between two ECUs. So that is nothing but in-vehicle network. So secure electrical and electronics architecture. This is called as an EE architecture. Okay. Next one, secure connected vehicle. So whenever we are connecting the cars to an internet or to the other car, so this should be secure. So that's why we have 4 different level of security layers available. Next, continuous engineering and support. Yes, we already told autonomous drive tool chain for continuous engineering. So a lot of tools are developed, like model-based design, coding, testing. So a lot of things are available. So whenever there is a change in one part of the code, then it will be automatically the model-based design will be updated, coding will be done, and testing will be automated. So everything will be automated. So this is nothing but called as a continuous engineering. Okay. So we are looking for the continuous engineering environment to support this autonomous drive. And architecture wise, as I already told, so we have the redundant architecture and open autonomous drive AD tool chain. So here we have all the things as an open architecture. So architecture definition, store deep learning, simulation and test, integrate, build, simulation based validation, test drive, and connectivity based validation. So this is nothing but the open architecture of open ADX, okay, where everybody uses the same. Next, HMI defines the relationship between the car and driver. So mainly the HMI plays a bigger role. So this is nothing but a human machine interface. That means a touch screen available to connect to our car. So right now this is a display from Tesla car. So where there is no other buttons available, only a 24-inch screen available, where everything can be controlled with this 24-inch screen. There is no other button available. Like even if you want to turn on headlight, so there will be an option available in this touch screen. Okay. Next, real world field data is the key remote validation. So all the data which is from the real world is fed into the server and shared to this car. Next, let us see how the automated driving situation in India. So here we have the different list from 2018, 19, and 20. And a lot of countries are having different positions in having this automated driving. Okay, out of this, Netherlands plays first role in 2018 and 19, and right now Singapore comes into the first. Okay, Netherlands goes to the second. Similarly, India was at somewhere at the position here in 18, and it is getting down year by year, and right now we are in the 29th position. Okay, so we are at a different levels with the policy and legislation. Also we are at 28, then technology wise also 28, and the infrastructure still we are not updating our infrastructure, and consumer acceptance still our end user or our people are not ready to accept this car. So we are at the 30th position in the consumer acceptance level. So this is the different level of our automated driving right now in India. So this is the situation of our automated driving in India. So yeah, this is my last line. Hope I have completed on time. Sorry, in between there is some trouble, so I can't able to make it. So I was a little bit rushing up some slides, but I will share you the slides, which is self-explanatory. Any questions?
Participants, if you have any queries. சரிப்பா